Okay, cool. And so this is the Data Dragons data visualization hackathon for May. And today we are discussing introduction to Jupyter Notebooks, Pandas, and a bit of NumPy, but mainly focusing on Pandas and just getting to grips with notebooks. So to preface this, there was two data sets given, the IMDB movie dataset and then obviously the pandemic dataset. And the real crux of this visualization or hackathon was really to get to grips with basically getting to grips with Python and also learning how to use an editor. Now, you don't necessarily have to use Jupyter Notebook. I used Google Collaboratory because of the fact that I am on a Mac, and Google Colab is just a bit easier to work with than with Jupyter Notebook, but that is kind of like an industry standard. Hi, Bradley. So yeah, so the way this is going to work, I'm going to first showcase my work, and then we can have an opportunity for other people to showcase. Cool. So, and at any time, you can feel free to ask questions. I did try to keep this to a more beginner-friendly standard, just so everyone can feel comfortable and so we can continue to build. So there's not going to be a lot of functions. I did try to keep things as standard as possible, and then to leave open avenues for further exploration. Cool. So as with any Jupyter or notebook, it's really great if you just put in a bit of information at the top, and then getting right into it, you always import the relevant modules. So I imported Pandas, NumPy, Matplotlib, and then Seaborn. Seaborn is just kind of like an additional library that you can use to pretty up or just make your graphs look more aesthetic and things like that. And so because I work with Google Colab, you need to be able to integrate within your own personal Google Drive, and then also import the CSV data. Okay, and from there, it's just getting all the values and converting it to a data frame. Then we go and get a basic overview of the data. So now the unfortunate thing when you import into Google Colab is that it doesn't always pick up what your first row's headers are. So you'll see here on your first try that it comes back with it has all 5 columns, but it didn't necessarily recognize that the first row are the headers. You have to go and set the first row as the headers of the columns. And so that's what we achieved there. Then you just have a basic description. If you'll notice on the pandemic dataset, there's 272 rows actually, and mine is 271. That's because there was one row that I just wasn't, before I realized that there was a way to fix the problem, I deleted it because I got really irritated. But you should not do that in an ideal situation. Cleaning of the data. So when you're cleaning, it helps to list out the things that you're going to do. The first thing before we do that is we make a copy of the data set. So if we make a mistake, we don't fudge with the whole entire data set. So that's what I've done there. Then I needed to drop the unnamed random column, which was basically the access column, got rid of that, and then you can see there. Now, no, just show me the thing. Okay, so the main things that I was interested in with doing this was showcasing how the length of plague pandemics has changed. And also because I study a lot of economics, I wanted to see which pandemics lasted the longest and like why. So obviously you couldn't get why from this data set, but it was just interesting. So the first thing I did is I went and split the dates. So as you can see, the dates had this I don't know what the word is, the hyphen between them, and effectively you had a split. If you notice in here, it's 2 different. That's because I have the hyphen on my Mac, and then there's the hyphen on Windows, and I had to spend a lot of time searching for it because, as you can see, my MacBook doesn't have that. So I had to go and find it online and copy it. Then I had to go and replace the circa and the BC. And then for end date, I also had to go and replace various items that were in the end date column, as well as fill all the NAs with the relevant start date. So that way you could see that the year was not greater than 1. That way you end up with like a 0 year length. So if we look at it, we have a start date and end date, and I'm looking for something that has the same end date. See, 2020 to 2020. So the Nigeria yellow fever epidemic did not last more than 1 year. Cool. And what's cool about Google Colab is that you can hit that little icon and then explore the data. Okay. Now, then I wanted to create a new calculated column, which is just the length of plague. And in order to do that, you need to go into it. 2 seconds. Okay, in order to create this new calculated column, I first had to change the data type to make sure that both start date and end date were of the correct type, which was an integer, because initially they were strings. And then from there, I had to just very basically minus the end date from the start date to get the plague length, which, as you can see here, is 742 years for the HIV/AIDS epidemic. Then I just did a very basic histogram plotting the length, and as we can see, it's a right-tailed distribution, showing that the vast majority are clustered at the beginning, and then they spread out far less evenly. Okay, so the average length of a plague is 4.3 years, which is obviously not ideal, but yeah. And then the 3 plague lengths that have that have greater than 100 years would be the bubonic plague and, of course, the Kuru epidemic, which I didn't really know about, so I found that quite interesting. Then exploring how location and diseases are related. So of all the plagues, only 26 have been affecting worldwide. And then we go through this and we just do a very basic query to go look at them. And then you can see a lot of them are influenza, cholera, and then you just see a lot of repetition with a couple like really interesting ones like MERS, and then hepatitis by adenovirus. So from there, and then we just have a nice bar plot over here about the length of a pandemic that has affected the whole world. And what is interesting is that the bubonic plague has affected the people for the longest time, with HIV/AIDS also being quite close. There we go. There. And then, of course, we look at the death toll. Yeah, and then I wasn't really able to come up with something great with the death toll, but I really focused on more the plague length and how long it's been around. So that was it. So I will allow some questions before we go and look at anybody else's contribution on either the movie dataset or the pandemic dataset. Does anybody have any questions or commentary at this point in time? Okay, cool.
Wait, sorry, I was trying to find the mute button.
Mhm.
So if you just go down a bit, I just want to see the HIV. It was scroll a bit more. HIV and AIDS. Oh, so that's HIV and HPV. So like it doesn't have HIV is not on its own.
Yeah. So
oh no, it's there. Sorry, I think it's there. The
yeah.
second one there. Okay. No,
Yeah.
so continue.
So I didn't combine them. So because these two were separate,
Yeah.
HIV/AIDS and HIV/AIDS human immunodeficiency virus. So something that we could have done, or I could have done, would have been to like further clean up the titles of the diseases. But I wonder if perhaps the reason that they separated it might have been that they might have occurred in different parts of the world. So they might be tracking it in sub-Saharan Africa versus worldwide. So that would be an interesting thing to see.
Okay.
Yeah. And then also all the different types of influenza, like the thing that kept coming up was influenza while I was looking at the disease names. So if that's the case, then like stripping out all the other parts of the suffixes and then just viewing the influenza by itself and seeing what proportion of the diseases are actually caused by the flu virus versus everything else.
No, I hear you. And then there's one last question here. I know I'm asking you to repeat yourself here, but just with the dates right at the very top, I think you can remember looking at this data set, and I think my worry was dealing with like the dates, right? So you see that number 5 there, row number 5.
Yeah.
So like dealing with something like that. So how did you clean that out? So was it just you found that one and then you just take out the C and all that, or how
Yeah,
did
so
you?
for like I did two different examples. So this one is like a hard replace where you just go and like you tell it to look for exactly that
Yeah.
thing, which is this one, and then you say replace with this. Or you say dot string dot replace, where effectively it goes and looks for everything similar to the space BC, and then it clears out everything to be a blank space.
Oh, so like it's almost like saying that whatever, if I'm looking at like a sheet, it'll say maybe if it contains anything along these lines, like BC with a space or whatever, remove it. That's
Yes.
the second one. Okay, that's cool. And then if you were to look at the numbers, I think the numbers were a bit weird for me, like number 4 there, right? Number
Do you mean
4
this
and
one?
yeah, sorry, row number 4 and then comparing to row number 3. So that like row number 3 upwards gives like a range, whereas number 4 gives you like a solid number. So how would you plot that as like either as a bar chart or whatever you want to plot it as?
Yeah, so I was also looking at how some other people have, well, nobody really, when I was looking at what the other people have done, has figured out how to work with the death toll exactly. And I had encountered an interesting problem while working with it, where every time I tried to strip out just the word million and replace it with 5 zeros, because the first number would obviously make the 6, that, I mean, 6 zeros, it kept on taking out million plus the 200, which is a weird error. But the idea is to strip out the million, put in 6 zeros next to that, and then to separate the two numbers so where you can get an average between them. The problem is when it's like an exact number, I almost feel like I wanted to work on it a bit in Excel first, but there must have been a better way, like removing all the as of 2021, all the as of December 22. That's just a straight of like remove things similar to a bracket or like suffixes. Like I think I did something over here which is similar to it. Yeah, so I created like a little function called suffixes and then remove all of these. And then everything that was in the array for suffixes then had to be removed. However, as you can see, it started to remove like everything. Like, so that was the problem. So that was kind of where I left it. But yeah, trying to find an average for each number was kind of where I was hoping to go, and then I was hoping to do a scatter plot between death toll and length of time. But it was a less easy one, the pandemic's data
That's
set.
interesting. And I think just last question, I think it's like very similar to a problem I had with the movie data set. So if you look at location,
Yeah.
so row number 1 has Europe, Asia, and North Africa, and then you have North Africa, Europe, and Western Asia.
I will show
So
you how I solved that on the
okay.
movie data set.
Oh, okay, cool. That's fine. I think we can just go there then. That's fine.
Okay, so the way you do it, where is the actors? I was hoping to not show this so we could focus on your work, but where is the genre splitting? Okay, so you do it by string.split. So you would take the location and you would obviously put the string data, and then you split by a delimiter, which in this case was a straight line.
Yeah, there's like a vertical straight line.
Yeah. But in the location dataset, it's obviously a comma, and then you use pandas. You basically follow exactly this, and then the important thing is dot stack, because that way, if you can see what is this now, cost. Okay. So now you can see here where this is now. Okay, so each line of this Jurassic World has a thing. So now you can see.
Sorry, I think you switched off your sharing, eh?
Oh my word, I'm so sorry. I've been talking about this.
No problem.
I can share. Okay, so you take the location or cost, and then you start string.split, and then so the dot stack. And because it's a stack, I'm just looking for the cost like field here. Show 25. Okay. Then you can see where each person is. Why can't I see the cost person? Genres. Okay, wait, what did I split? Yeah. How come I can't see him now? Okay, the point is that you're going to see each person, if it's not cutting off, in a line under line. It creates multiple lines for the same person. So if I run it data frame.
Okay. So if it's a line per person, it's a line.
So if you see the tagline, the pass is open, the park is open, sorry. Because there were 5 lines before this, you can now see that it's got line per line. It's because it's splitting per line. So if there were 5 actors in it, it's very frustrating. You can now see. That's why. Oh, is it just data frame? It's really hard to work on things that you worked at while you were studying. Now you don't remember what you were thinking when you were studying. Oh, there it is. Chris Pratt, because they were each in the movie. So yes, and now you can see each of them, because even though they were all originally part of it. So what it's done, it has stripped them out and then repeated each of the lines. So this data is repeated 5 times.
So then would that mean like I'd create like another data frame specifically just for this? If I'm saying I want to, because it's the same problem with genres and production companies. So I'd maybe create a separate data frame like you did. Okay, you did create a separate one, and then you'd analyze that specifically for whatever you want. So if it's the actor that occurred the most in the data set, or the most revenue, or whatever it is, or type of movie that he acts in, or she, whatever.
So this is what the cost. Just want to see. Okay, so you can see it now, those 5. Now you append, you join it on the same thing. So the way they have the cost joining to each other, and I think they join on index, if I was correct in this. Yeah. Okay. So then you append them, and then you can just create to your original data set. Obviously, after you've made the copy, like please, if you've learned anything from today, make a copy before you analyze anything, because that way, if you make a mistake, you can just go back and redo the copy and don't have to go to the very top of your notebook and start all over again. But yeah, this is like quite a useful thing to learn the split. And I never thought of doing it for production company, but if you do it for cost, you do the same thing. And I see I did it for genre as well. So yeah, just so where you can separate, because I mean, it's very useful. This is how I figured out, I think, Michael Caine's most profitable genre, I guess, animation or something. Not Michael Caine. The most profitable genre for someone was animation. Yeah, I can't remember who, but one of them. Yeah. So yeah, that's it from my side. Then Wabo, take it away. And anybody else is free to show as well.
Share my screen, entire screen. Sharing screen number 2. Okay, cool. There you go. So I chose to look at the movie dataset. It just but yeah, my reasons were it just looked like one that would be easier to understand. And just by looking at the attributes that were there, I could almost tell that I could look at revenue versus budget per genre, or per director, or by production company, or which production company made the most revenue over a certain year, or whatever maybe. So it was felt easier to just analyze that one. So one that I decided to look into was just the comedic drama movies. So I do like this type of movies. So I was like, let me just try find something that I actually like, and then try to also reduce the data as much as I can, just to focus on that aspect of the entire data set. So yeah, I don't have like a structure here, just a lot of trial and error and messes, but I left them in there just for my own learning. I'll come back to it. But there wasn't too much cleaning. I did find some surprises here and there where, for example, there was amounts for like a budget, it was a zero, or there was like weird text. Like I think for like Korean movies, because they have their own they have their own characters and all that. I didn't pick up those things until like now. Literally, I think tonight I was looking through some of the data, so there's something that could have cleaned there. Then yeah, going back to like mistakes and stuff. So these are the type of things I'm talking about where I tried to plot something, came out as a mess. But I did take them into a sheet and then try to plot them there. And then I just found the solution through using a sheet, which is what I'm more familiar with. Okay, in any case, so the things I looked at were the key one was just this here. So this is this here is just a representation of the comedic drama movies, and their revenue versus budgets over a period of time. So I limited the data set to 2000, the beginning of 2000 up until 2015. Then what I found is that uh, um, they do actually make quite a lot of revenue, but they're actually interestingly weird points like these here. So yeah, so this point here, these points are interesting for me. It's a point here, over there, and then somewhere this area here. So I did wonder if it was a thing that maybe, I don't know, because when I looked at it together with the number of movies that were made in this in a period, there seemed to be some sort of just by pattern, right? Just my eye seeing what the pattern there. It feels as though maybe movies would be produced during a certain period, and then maybe 5 studios will all release their movies at the same time. Hence, maybe the spikes during certain periods, or at spikes during certain periods, and also revenue during certain periods. And this made me think of how, for example, now in June, I think the big blockbuster movies that are coming out is like Oppenheimer, Spider-Man. I think Barbie's coming out. So all these big movies are coming out, and I think if someone was to maybe plot the revenue for this year for movies, there'd be like a huge spike maybe in June, because that's where all the big movies came out, and then all these weird ups and downs maybe would be where, for example, what's the movie that came out now? Guardians of the Galaxy came out before that June period, so maybe they produced quite a lot, but not as much as maybe where a group of movies came out where like there's a huge spike in the revenue. Don't know what else I tried to look at here. Yeah, this is one of my mistakes here. So I think I was just trying to plot a scatter plot to see like a relationship between the number of movies produced and the revenue. I think I was just curious to see what was going on there. I think I did make a regression line. So again, right, assuming that this is correct, I really don't think it is. But I just from what I was seeing, I was like, oh, maybe there isn't much of a relationship between the number of movies that are made and the revenue. Could be wrong, it could be right, but yeah, I just decided just to make this visualization just for practice purposes, and just to see what I would get and how to actually make a scatter plot. And yeah, that's just all I had. So just like the revenue numbers, the number of movies made per period, and then just a scatter plot there. And yeah,
That
that's all.
is amazing.
Thank you, appreciate it. Let's see. Share.
All right, and that is the end of the video. Thank you so much for watching. I hope you got some value out of this and that you learned a bit about how to work in a notebook, how to utilize pandas and numpy, and various operations. So yeah, I will be seeing you next week. Bye.